Good morning. Good to see you all up and early today out here at the conference to check out what we've got. So my name is Rob Chambers, and today I'm going to talk about the new Cognitive Services Speech SDK. We're going to learn a lot of things. We're going to figure out what the SDK is going to do. We're going to figure out how you can get the SDK, what sort of solutions you can do with it. And we're going to see mostly code. There's just a handful of slides. So we're going to jump right in. With this new Cognitive Services Speech SDK, we have many goals. One of the goals is that we want to support all speech scenarios. In the past, we've had different SDKs for different solutions. We've had one inside Windows. We've had one that you can run on a service. We've got one that's cross-platform. They're all different. They all do different things. We actually want to have one SDK that we can do all of the speech scenarios. We can run it on all of the modern platforms that exist that you need, our customers, and that we can access in all of the modern programming languages. That's a very big goal for us. So we don't have all of that today, but we've made a very good first step. And hopefully by next build, we'll come back and be able to tell you we're completed with that task and show you what that looks like. We also wanted to focus on, is this easy to use for everybody? Sometimes one of our SDKs might be easy to use for people that are beginning for speech applications or they're simple speech applications. But sometimes you want to customize it. But if you use that SDK, you can't. But if you use the other SDK that you can customize, then it's not easy to use initially. So we want to build, again, one SDK that can go from novice to expert. Things you learn when you first start, you can continue to use. Additionally, over time, we'll support the online use cases, offline use cases, and hybrid. We'll also support interactive use cases when there's a user right there, or when there's not an interactive user and it's a batch processing job where you might have a lot of audio data that you want to process. So with that, let's take a look a little bit more detail about what those things mean. From a scenario perspective, oftentimes developers just want to get the text. They don't need anything else. That's just all they need. So we want to support that. Sometimes, though, they want to go further than that. They want to understand what the user actually meant by what the user said. That's both in batch cases and interactive cases. So we've integrated with the language understanding service so that you can use both of these together at the same time. And we've optimized it to be highly performant. So instead of it coming back to your client and then going back to the service, doing all that service integration, we've done it for you. It's one API, easy to use. Additionally, we've heard from customers that they want to do translation. So for example, I'm from Ohio. I speak one language, English. I speak 3 phrases in other languages. That's about all I get. What I'd like to do over time is be able to make my application in English, but then actually just deploy it and say, well, this user is going to speak French. Just take care of all of that for me, right? We're not there today, but we do have translation integrated in that you can get translations from speech to text, or you can go from speech to speech. And in fact, our own translator application is moving to use this SDK in its next release. From a platform perspective, we want to support all of the platforms. Today, we're announcing that we're on Windows 10, we're on Linux, we're also on Android with the Devices SDK that you heard Satya talk about in the keynote. Using that Android speech SDK, same SDK as everything else, you can also do keyword spotting. So that's one of the other interaction models, where some interaction models are you press a button and you talk to the system, and then you get one response. That's what Cortana does on mobile applications and on the Windows 10 experience. Sometimes you want a continuous listening, where the user does something, and now it's listening, and it listens for a long time. That's what our dictation experience does in mixed reality, in HoloLens, and on the soft keyboard on Windows 10. But sometimes you don't want the user to touch anything. You just want them to be able to access it. They're maybe doing something else. Their hands are busy, or they're too far away from the machine, and that's called keyword activation. So that uses components that are called keyword spotters. So we want to have all of that integrated. And then from a programming language perspective, we want to make it available to everybody, no matter what language you're programming in. So for today, we're announcing that we're supporting C# and .NET framework. We're doing C++, C, and Java in that Devices SDK. And then coming soon, we'll have iOS support, as well as Swift and Objective-C. We'll have OS X support as well, and other platforms that you think are important. So when you need a platform, let us know what those are. And after we've heard from enough customers, we'll try to support all of those platforms, again, with just one speech SDK. From an ease of use, as I said, you want to make it easy for developers that have no speech experience at all, or the applications are fairly straightforward and simple. then you can learn and take our state-of-the-art, out-of-the-box capabilities and take advantage of them for yourself. We're basically giving you everything we've done to make speech amazing and intent amazing and make keyword spotting amazing for Cortana, for the holographic experiences, and for Xbox. You can then take it further by building your own intent models. You can take it further by building your own keyword spotter models, your own language models, your own acoustic models. Many people don't need to do that. Some people do. So if you do, it should be easy, and it's still just one SDK. All right, that's enough slides. Now we're going to look at code. How many of you in the audience are developers and write code? Oh, that's fantastic. Everybody else that doesn't, raise your hand. You know people that do. You wish you did, maybe, or no, I don't know. OK, so let's jump into some code. So what I'm going to show you is I'm going to show you this running on my Windows 10 machine. Later today, you can see it on the devices SDK running in Android. I'm going to show it to you right here in C++ and in C#. And if you want to see the Java implementation and how that looks, very, very similar, you can go to Grace and Sarah's presentation later in the day at 4:30. All right. So with that, let's actually do the demo first, then show you the code. So what we're going to do is we're going to run this demo. It's a console demo. Works in graphical applications, consoles, whatever you want to do. I'm going to show you some speech things. So let's do the first one first. We're going to do some simple speech recognition. Hello, my name is Rob Chambers, and I'm excited to have you watch this demonstration. Aha, that's better. User error, sorry. See, speech recognition should be easier than AV. All right, let's go back to the demo. So, first demo. Hello, my name is Rob Chambers, and this is a demonstration of speech recognition. Now, did you feel that anxiety that you all had? Yes. Right? Because I sometimes have that too. And that's because I wasn't showing the user what was actually going on. So don't do that. So
Did you have to train your voice?
I did not. This is out of the box. No customization in the demo that I'm going to show you today. So this is if you want to do, you want to get the result and do something with it. But don't do that in your experiences. We've learned that users want to know what's going on. Otherwise, they feel like you did. And you're like, oh, this demo's not working. Or right, don't do that. Do this instead. We have intermediate results, so as we're recognizing, we can actually tell you what's going on, and you can use that in your user experiences. My name is Rob Chambers, and hopefully this will make you feel a lot better, because as I talk, more and more words come out onto the screen. Right? Pretty cool, right? All right, so that's using those intermediate results. Now, each of those times I had to press something to make it go. I'll do some questions at the end if it's OK. As I was going, I had to press the button each time I wanted to do something. That's kind of lame if I wanted to speak for a long time. So let's look at continuous recognition. This is continuous speech recognition. It'll recognize one thing. Whoops. It'll recognize one thing. And then you can recognize more things. One after the other. The user can get everything that they need to do. All right, so that's continuous. Lots of good examples. Let's look at some code, because I love code. Now, how many lines of code do you think all those things took? Who wants to guess? Anybody? Oh, come on. How many? 25? OK, good guess. 8. OK, let's see what it is. I think I beat both of you. All right, there you go. That's the first demo. So what you do, So what you do to get the first demo, screen, stop scrolling, there we go. So we have this concept of a speech factory. You can get a speech factory object. You use your subscription information from Cognitive Services. You get a factory. That factory, you can create all these different kinds of objects. You can create a speech recognizer object. You can create an intent recognizer object or a translation recognizer. They're all individually tailored for those scenarios, so they have exactly what you need on them, but they all feel like they're friends. They look the same. They have the same kind of concepts. It's a little bit like in C#, how all of the collections feel similar, but they're all actually different. They're tailored to what you need. That's what happens here. So you get your subscription. You can create your recognizer. If you wanted to create a different recognizer, you can do that. Intent recognizers, translation. There's going to be a whole bunch more of those as they show up. You get your recognizer, then you tell it you want to recognize. That's that single-shot interaction, right? In C++, we're idiomatically correct. We actually return an STD future for you, so you can use that and wait on the response, or use it in whatever way you want. In C Sharp, we return an awaitable object, so you can integrate in that particular way. In other languages, we do async programming. We match what's there instead of making you be like, why are you doing something different? And then the result objects here, there's not a lot of huge amounts of things on it because we're trying to make it simple and easy for you to use. All right, intermediate one. Pretty simple as well. All we did, one more line of code. We hooked up an intermediate result. And then what that does is it actually prints out on the screen what's going on. That's the same result I could have gotten back from the asynchronous call. I just get one, and it's marked as an intermediate reason. That's it. All right? Continuous recognition. Well, for this one, you have to do a couple different things. So instead of telling it to recognize async and you get the response, you just tell it to start. And then you also hook up another event handler, which is the final result event handler. And inside that thing, I'm just printing out the final result. That's all that is. All right. So we talk about making this easy to use. I think that's really pretty easy to use. If you want to do more customizations, you can, but I'm not going to show that because we don't have time. But you can go and download our SDK to take a look at that. All right, back to the demo real quick. Let's show what intent recognition's like. We've integrated with Lewis. I've gone up and made a Lewis application. That application's got a handful of intents in it. Actually, it's got like 35 intents in it for different places in my application. Users can do different things. So what we've done here, let me show the number 4. I want to watch TV. And so what happens is, all on the service side, we send the audio up to the service, we recognize the text, we actually communicate with the Lewis backend to actually understand what you wanted to do, and then we return that content back to you. Only one connection to the service is not a 2-connection kind of thing. It's a lot faster, it's a lot more reliable. We also optimize speech recognition. For all those examples that you type in for the language understanding service, we take those and make the language model better and easy for you. You don't have to do it. We just do it for you. You've already given Lewis the examples. Why should you have to give speech the examples too? All right, so that's intent recognition. Obviously, we've got continuous versions of that as well. It looks the same. Let's look at the code to see. This time, though, let's look at C Sharp. C Sharp code, it's all the same. You got to download the SDK, get the new namespaces, get your subscription keys. There's that speech recognition example that I showed you a long time ago, just doing speech recognition. But if you look down here at the intent ones, open that guy up. Let's look at this one. OK, same kind of concept. You get your factory. But here, I'm using my Lewis subscription, not my speech one, because that way I have access to all of my Lewis information. And I create the same factory object. In here, it's very similar code. I've got an intermediate result handler. I got this recognize async method, but it's awaitable, so I can use that. And I'm using that call there. So how do I tell it where my Lewis model is? We've got this concept of a language understanding model. So you tell that what your app ID is, and then we just do everything else from there. Here, I'm using 3 specific intents. Like I said, I had 35 of them up in the service, but because I'm telling the system, these 3 are the ones the user can do, because my code can only react to these 3. So you let me know if they said one of these 3. The recognition will happen. We optimize the recognition for just those 3. So it's actually more accurate in that situation. And then continuous is the same. I didn't show it to you, but same kind of concept, right? So you come in here, and you see that start continuous. There you go. Wait until we press a line, et cetera. All right. So that's intent recognition. What else can we do? Well, I've shown you this single-shot interaction model. I've shown you a continuous interaction model. What would keyword spotting look like? How many lines of code do you think that takes? Anybody? How about 1? How about 1 more line of, well, OK, that's the lie. It's like 2. But it's not too bad. Let's take a look at the, instead of showing you the experience, you're going to want to see it. You've got to come see it. Grace and Sarah are going to show it to you at 4:30 today on a piece of special purpose hardware with an array microphone. Go see it there. But I'll show you some of the code. They're going to show it to you all in Java, but I'm going to show it to you in C Sharp. OK, or C++, actually. It doesn't matter. They're all the same. Keyword. Here, what we got. So let's say I want to do the intent recognition. Same thing, get a factory, use your keys, get your intent recognizer, which was the strongly typed object when you're doing intent, hook up my result handlers. All that stuff's all the same. You learned that once. Why are we going to make you learn it again? It's all the same. The only difference, really, are these 2 lines of code. So like the language understanding model, we've got a keyword spotter model. You tell us where it is. So we've got a custom web service and web portal that you can go to and build your custom keyword model for your keyword. You'll see later we've got some built-in ones, for you to play around with. But if your app name is, let's say it's TiVo or Xfinity or something, you can make that be your keyword. download the model, hook it up, everything's good. When you say start keyword recognition, we're not going to send audio to the service. We're doing a keyword spotting job locally on the device, saving you power, saving you network bandwidth and charges. It's all going to happen locally. Once it happens, we then do the right thing to splice the audio and send it up to the service. We verify the keyword, comes back down. It's all the same. Programming model is identical. The rest of your code doesn't know you were using keywords versus anything else. It's all the same. All right, so that's keyword spotting. Let's go to, machine translation. Oh, I love this one. This one's really fun because I don't really know any. Anybody speak Spanish? Awesome. Anybody speak French? Good, got a French back there. Anybody speak, let's see, what else did I put it? German? Anybody speak German? Okay, cool. Let's see what we do. I'm translating into those 3 languages. Number 8. How are you today? Uh-oh. That's okay. It's a demo. It's a speech demo. Things happen. We're going to do that again. How are you today? And it's not very happy. Tell you what, let's try the other one. Let's go back to my code. I'll run it in C++. Boom. Number 8. How are you today? I don't know, my Wi-Fi doesn't seem to be working well. Oh wait, it's hearing me. Speech demos, you know, you gotta love them. Let's try one more time. This is a test of speech recognition. You usually do really well. Why are you letting me down? Well, you would have seen something really amazing. I'm going to kill that. You would have seen something really amazing. It would actually translate. You can access each one of the translations independently. So let's look at that code to see what that looks like. Let's look at it in C#. Okay, so you come in here, you get your factory again, same stuff. We're going to make a list of strings, which is where I want to get it translated into. And then when I create my translation recognizer, I tell it what language the user is going to speak in, and I tell it what languages I want it to come out in. And really pretty much else, the rest of the code is the same. There's one cool thing on the result, though, when you get the result back, is there's this there's this translations, oops, sorry, it's in here. There's this translations object on the result object that I can specify what language I want to pull the response out. So I get the text in the normal language, but I can also get the text in all the other languages. This is a great first step for us. Longer term, I really do want to deliver that feature where you can write your app in English or in whatever language your native speaking is, and then everything else will just happen for you. Why do you guys all have to be experts in language? We can be experts in language for you. But then if you want to take it further, awesome, right? This is the whole goal of making easy things easy and allowing you any kind of customization that you want to have. All right, so back to the slides real quick for some summary, and then we can ask some questions. So, right, here we are. In summary, all the scenarios, all the platforms, all the programming languages, all the developer level experiences, eventually online, offline, interactive, and batch, one SDK, one device SDK, and you can start for free with a free Azure trial. I don't know why you're not going to go back to your hotel and just do this right now. Sounds like a great idea to me. Got a couple more sessions. We've got a theater session for the devices SDK. We've got a breakout session where we're going to talk about all of the richness of the customization. You're going to hear about speech synthesis as well, how you can make your own custom voice fonts. You're going to hear more details about translation. I'm sure their demo will work. I've done something wrong with my Wi-Fi or something. And importantly, please go evaluate the session. We're going to know if we did a good job or if we need to improve in the future. I really appreciate your time. Any questions you have? Yes? Session slide. Oh, so sorry. Yes, the locations are reversed. Good catch. Silly. All right, questions? Yeah, in the back.
Languages, are you going to be able to support Python anytime?
It's on my, yes, on the list, right? We actually have it working in development right now. I do a bunch of my testing in Python. We just didn't have it ready for build, but we will. Additional languages, we're going to have Python. We're going to have, obviously, Swift and Objective-C. We'll go GA with Android as well, and Java. JavaScript. We want to support, hopefully, Ruby and Go. If there's any other languages you want, send us some mail and let us know. Okay? By the way, sending us email is easy. I'm Rob Chambers. You put a dot between my first name and my last name at Microsoft.com. Pretty straightforward, and I'll try to respond to you best I can.
In your demo, you had a US,
Language understanding model?
was it like a profile? Was it like a profile that you wrote your source? It was like Lewis, called it LUIS.
Oh, got it, Lewis. So there's a Lewis subscription. That's an abbreviation. The language understanding service is it's not Lewis, a person. Yeah, that's a good question.
I was thinking Luis.
No, no. So she was asking if we loaded a particular profile. This is untrained. System's never seen me, and I've been working on speech for 20 years, and I've never let my audio go into the system because I don't want it to be. I don't want to be special. I want to experience it like all the users do, and that's just the recognition that I get. Question over here? No. Yep.
Actually, your name is Propanome, but how could it recognize your name?
One more time.
How could it recognize your name? It's a Propanome.
We actually train on large amounts of corpus data. So, Bing obviously searches the entire internet. We know everything about the internet. We use all that linguistic data to train our language model. So people like me with my name happen to be on the internet. And so we learn those things. So very, common names, even not common names. I could have shown you, like I read the news at night with my wife on our big screen TV. I use Cortana. It's the same technology. Sometimes I want to learn more, so I'll ask her a question about some random thing I've never heard of, words I've never even known. And the recognizer, because it trains every night on new things, it knows them all. Other questions? Okay, great. So who's going to go back to their hotel room or back to their place of business and download the SDK? Okay, that's pretty good. I'll be watching.